Alright, so we're given these two complex numbers written in yellow, and the first thing we're asked to do is add them. We need to do it algebraically as well as using vectors visually. And so algebraically, we'll just combine like terms. 4 and negative 1 will give us 3, and then I and 3i, or in 2i will give us 3i. So algebraically, that's how we do it. Using vectors, we're going to draw this. So we go 1, 2, 3, 4, up 1. And then, since we're just adding this, we're going to go left 1, up 2 from this point. And then if we draw the answer from the origin to the end, we see it's 1, 2, 3, 1, 2, 3. So that would also be 3 plus 3i. Alright. Now if we do this one, we're going to have 4 plus I, then we're going to have a negative sign, and then we're going to have 2 times everything in here. So we distribute the 2. Distribute the negative. And now it's just an addition problem. So we get 6 minus 3i. And that's our answer algebraically. Now we go 1, 2, 3, 4. Oh, whoops. That's not what I want to do. I'm going to take this one because it's z1 minus 2z2. So z1, 1, 2, 3, 4, up 1. And then from this point, we're going to go the opposite. So actually, I think the best thing to do is take this, which was this. So 2z2 is 2 minus 4i. And so we're going to go 1. Actually, let's do it the other way. So we could do it that way, but if we take the opposite of z2, or actually let's even just draw z2. So z2 is going to be left 1, up 2. So it would be this. So if we go from this point, we go left, up 2. Instead we're going to go right, down 2. Then we're going to go right, down 2. So we went down 2 twice. So arrow, arrow. There's an arrow there as well. Okay. So if we go from here to here, we go 1, 2, 3, 4, 5, 6. And then we have to go 1, 2, 3, down 3. And that ends up giving us the same answer right there. Okay. And then this last one. Okay, so algebraically, we have 2 times z1. And then we have the conjugate of z2. So that just changes the imaginary part. Distribute, we get 8 plus 2i. Minus 1 minus 2i. These cancel. And we're just left with 7. So algebraically, that's what we get. Okay, using vectors, we're going to draw z1 twice. So we're going to go 1, 2, 3, 4, 1. Then we're going to go 1, 2, 3, 4, 1. Okay. And then we're going to add the conjugate of z2. So I'm just going to draw z2. And so, or actually, just the conjugate is changing that to a negative. So we're going to go back 1, and then up 2. Oh, whoops, down 2. So back 1, This is kind of hard to see. This is right here. This is throwing off. Okay, so back 1, down 2, gets us right there. And so if we draw a line from here to here, we see it's 1, 2, 3, 4, 5, 6, 7, and it's just on the real axis. And so that's how we know that it's 7. Okay, and one more.